All right. So, we are going to finalize the Pythagorean unit today by also using the Pythagorean theorem to find distances between points. So, in the past, if you've had 2 points, you could find the slope, okay? And just to give you a heads up of what that would look like, if you had 2 points on a plane, you could find the slope by finding the vertical distance and the horizontal distance, right? Suppose this was 9 and this was 7. And then you would divide the rise over the run to get that the slope was 9/7. But what if you wanted to find the distance between this point and this point? What we're actually looking for is this distance right here. We're not looking for the slope. We're looking for the distance. You can use a Pythagorean theorem to find that distance. Okay? Let's make that into a right triangle. And it's super interesting. It's super fun. Well, yes, it's super fun. I'm going to show you how to do it with the pictures, and then we're going to try to do it without the pictures. Okay? Just bear with me. So, I'm just going to think of 2 random points, and I'm going to make them both positive, okay? So we don't get thrown off by the negatives. Although, if you're having troubles with negative numbers, let me know so I can give you some additional practice, okay? So suppose we have the points 2, 6, and, 5, 10, okay? So, if we were to graph these, right? Here's my graph. Here's my x-axis, here's my y-axis. 2, 6, let's just say this is 2 and this is 6. Okay, and then 5, 10, this is 5, and this is 10. Let me write this out. This is 2, 6, and this is 5, 10. So, obviously, I would recommend you connect the points. Then you build your right triangle, right? Similar to how we were finding the slope, you're going to build your triangle. So you would do this, right? Drop it. And then draw this. Let me erase that little part right there. Draw the little right triangle symbol. And then you do need to find the vertical and the horizontal distances, okay? So the x values went from 2 to 5. What's the difference there? 3, right? Because 5 minus 2 is equal to 3. So this is 3. And then what about the vertical distance? Let me use a different color for that. Let me use red. It's 6 and it's 10. So what's the difference between 6 and 10? 4, because 10 minus 6 is 4. So this is 4. If you think about it, we now have a triangle, right? I'll redraw this triangle over here. We have a triangle, a right triangle with distances 3, 4, but we don't know what the long side is. We can use a Pythagorean theorem. Okay? A squared plus b squared equals c squared. 3 squared plus 4 squared equals c squared. 9 plus 16 is equal to c squared. 25 is equal to c squared. And if we take the root of both sides, right, because that's the inverse of squaring, we get that c is equal to 5. So the distance between these 2 points is 5. And we use the Pythagorean theorem to do that. All we did was graph the 2 points, drew the right triangle, we found the horizontal distance, by subtracting, right? That's how you find the distance between two numbers. You subtract. We found the vertical distance again by subtracting. Once we found out those distances, we placed them into the Pythagorean theorem to find the distance. You can always do this. You can always graph the 2 points, draw the triangle, and do the same thing we just did to find the distances. But there is a formula. We're going to call this finding the distance. I forgot to title it. There is a formula that you can use. All you got to do is plug in the numbers, and it will give you the distance. And I will give you the formula, okay? I'm kind of iffy right now, but I'm going to give you the formula. And you're going to be like, what the fudge is this? And then I'm going to explain the formula, okay? The formula to find the distances, suppose we have 2 points, x1, y1, and x2, y2, okay? These are just 2 hypothetical points, and you want to find the distance. Well, the distance between them is going to be the square root of the difference in x values squared plus the difference, the difference in y values squared. This is probably nonsense to you, and it should be nonsense, but let me explain to you what it actually means. You're going to graph, right? Suppose you have the points x1, y1, and x2, y2. Let's just say this is x1, y1, and this is x2, y2, okay? You're going to draw the triangle associated with it. If you want to find the horizontal distance, what do you do with the x values? You subtract them, right? Usually it's the bigger x value minus the smaller x value. In this case, x2 is more to the right, so that's what I'm gonna do. So the distance here is x2 minus x1, whatever those numbers are. They don't even have to be positive or negative, it doesn't matter. x2 minus x1. The vertical distance, again, it's going to be the bigger y value minus the smaller y value. The y2 is taller than the other y, so I'm just going to assume that's the bigger one. So it's going to be y2 minus y1. This is a right triangle. We have the vertical and the horizontal distance, but we don't know the long side, right? This side over here. So let's call that d for distance, right? Because we want to know what the distance is. So according to the Pythagorean theorem, a squared plus b squared equals c squared. A, in this case, is this weird x2 minus x1 squared plus, and then y2 minus y1, that's the vertical distance, and then instead of c, we're going to use d for distance. Now we're trying to solve for d. What's the opposite of squaring? Square rooting. We're just taking the root of both sides. So now we get d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's exactly the formula that we have up here. This is called the distance formula, because you use it to find the distance between 2 points. And if that confuses you, just like I was telling my 9th graders last year, as long as you remember the Pythagorean theorem, a squared plus b squared equals c squared, you can always draw a triangle and write out the distances and use that, okay? I personally hated the distance formula because there's just too many numbers to worry about, too many minus signs. My math teacher told me just draw out the triangle. It's going to be easier. And it is. But I'm going to do an example using the distance formula and using, actually, let's use the 2 points up here. 2, 6, 5, 10. Okay? 2, 6, and 5, 10. First things first, you gotta label them. So this is gonna be my x1, y1. This is my x2, y2. So if I want to find the distance, I would first write out the formula. x1 minus x2 squared plus y1 minus y2 squared. If you're wondering why I switch between y2 and y1, it doesn't matter. Because since you're squaring it, you're still going to get the same the same number back. If that makes any sense. Okay, so let's just fill it in then. x1 is 2, x2 is 5, so we're going to do 2 minus 5 squared plus 6 minus 10 squared. 2 minus 5 is negative 3 squared plus negative 4 squared. That's going to be 9 plus 16. That's 25, which is 5. So it works. Now, you could have fixed it right up here. You could have done 5 minus 2. That still would have given you a positive 3. And a positive 3 times itself is positive 9. Right? Just like a negative 3 times a negative 3 is a positive 9. So that's what I mean by it doesn't really matter if it's x1 and y1. X1 or x2. It doesn't matter the order. And that's it, actually. Okay? If you're having any issues, seriously, I'm not going to know unless you tell me. So, hopefully I see y'all during office hours, all right? I'm going to go ahead and upload everything for the week so that you have it and you can get started on it if you want. That'll give you more time for other classes instead of waiting for me to post daily assignments, okay? Nonetheless, wash your hands, be safe. Appreciate those that are around you right now because you'll never know when they're gone, okay?